again. Yes. If you don't think this data set right here is bell-shaped enough, if you think it's too skewed, then that's okay. We have another method that works for all data sets, not just bell-shaped ones. What I want you to do is to turn a second plot on, though. I want you to turn on a box plot on top of this. So leave this guy on. Leave this guy on plot 1. But now turn plot 2 on. Turn plot 2 on. Scroll down with your pointer, and you see how you actually have 2 box plot icons? You've got the left one and the right one. They're both box plots, but the left one will show you outliers, comma, if you have them. But not based on Kelly's mechanics, based on a different set of mechanics. We'll get into what that is in a second. So let's select that one, because that will be helpful to know if there are outliers. Matter of fact, I always select that one, if given the choice, because I kind of want to know if there are outliers, and I want the machine to do the work for me. Okay. List 1, list 2, we're good there. The mark is set to be at the square. I like that one because that's the mark for the outlier. If there are outliers, it'll make a nice big square on the outlier. So go ahead and press graph. Okay, so this is a pain in my butt. What I want to do is I want to adjust the window so that I can see everything better. Now, we already changed the X scale, right? So I really can't change that much more. What I'm going to change now is I'm going to make the Y max bigger. I think 15 ought to do it. What that'll do is it'll just free up some space above the histogram and put the box plot up there. Nice! So it's saying there is an outlier. Yours is too? Oh, it's all good. You just got to make your window bigger. Just got to go a little bit higher, Lloyd. I made this be 15, and that puts it up top.
Oh, okay.
Now I got some problems with this. That sounded very De Niro. I got some problems! First of all, that's a box and whisker plot, right? Right?
Yep.
Remember how the box and whisker plots yesterday had a line down in the box somewhere to show the median?
Right.
Where the hell is it?
It's the entire.
Oh. Remember what the box plots show you. Remember what the box plots in general show you. Here's a general box plot up here. There are 4 regions, right? There's a region 1, region 2, region 3, region 4, yes?
Right.
What do each of those regions show you? Quartiles, which mean we break the data up into 4 equal chunks that are what percent each?
25.
25% each. Do you see how a whole bunch of you said I was 70 inches tall? 10 of you. That's just about exactly half of you. That means you guys span 2 of those sections, essentially. Does that make sense?
Oh.
Now, if you don't, and this happens, again, in small data sets, this happens quite frequently. Do this for me. Press the trace button on your machine. Press the trace button on your machine. Now, push the up button once. This puts you onto the box plot. It's telling you the minimum is 69. Arrow over to 1 to the right, it's telling you Q1 is 70. What that tells you is, roughly 25% of the class said I was below 70 inches tall. And when you look at the data, you're like, wait a minute, that's not right. Only 1 of you said I was below 70. But you got to remember, so many of you said 70. It's throwing some of those 70s into that range and also in the next range. Does that make sense? Which is why the median is also 70. So there is a median. It's just sitting on top of Q1. Then Q3 boop, is 71. And then look at this. It says X equals 72. And it's calling that 73 an outlier. Who said I was 6'1"? You're now an outlier. Candace, you're now an outlier. How the hell are you an outlier now, but you weren't an outlier before with Kelly? Simple. It's a different calculation. So, remember the calculation we did yesterday. We took, you might not, it's totally fine if you didn't. We took what's called the IQR, right? We take the IQR. Now, the IQR is the distance between Q1 and Q3. So what is that distance in our data set? How far are these apart? Just 1. It's very, very tight because you guys all get... Seriously, this was the tightest I've ever seen. I've never seen only 5 inches of difference from 69 to 7. That's only, 5 inches of difference. Usually it's like 8 or 9 is much, much wider. So you guys are freakishly precise. Way to go. So 1 inch is the IQR. Now, by convention, and I have no rationale for this, we multiply that by 1.5 to make 1 inch, 1.5 inches. 1.5 inches. Got me so far? Then we take that 1.5 and we stack it onto Q3 and we stack it onto Q1. So what it ends up doing is it ends up throwing up a different set than the 2 standard deviation set. And anybody's guess outside those red squiggly lines is called an outlier in this respect.
Not an outlier.
You are. You're outside. There you are.
Okay.
You're the only outlier, though, Candace, because you're outside of 72.5 inches. Now, one might argue that if we throw away the precision of the half, that should round to 73, and you wouldn't be an outlier. Being an outlier isn't bad or good in this. It's strictly neutral, right? Strictly neutral. But the idea is, yeah, this does give you a different region, doesn't it? It gives you a different region, but that's because it's based on a slightly different calculation. This calculation, number 3, is an outlier is going to be any data. Now watch this. I'm going to write it in mathematical symbols. Hopefully you can make peace with it. Hopefully you can make peace with this. Any